All right. Welcome to the weekly EZKL community call. It is June 12th, and we have a lot on the agenda today, but want to start with the MNIST benchmarks with Georg. Since you have to leave early, right? So we might as well talk about those now.
Sure, that would be great. Thank you.
Awesome. Yeah, go for it.
Oh, I just asked some questions in the Telegram channel, and basically trying to find out basically all the different approaches. What's the trade-off between like accuracy of the model and the prover time? And so I was trying to do some benchmarking, and I was just wondering, specifically on the MNIST data set, at least to start with. And I was wondering if you already know some configuration that work particularly well, because my first approach would have been to just go with something like Linnet and try it out, but that might not be the best configuration, right?
Okay, well, you are actually in luck, because yeah, the the next PR we're rolling out has what we're calling this calibration function. So you can basically so you basically run this function and it picks all the hyperparameters that you need, but you can pick it based on two different basically metrics. One would be like numerical accuracy, and the other one would be optimizing for proving time. So you'll literally be able to generate all the hyperparameters that you need that optimize for one or the other, and then compare between the two. So that'll be covered, which is quite cool. And then I guess on the Python binding side, like JCM's been working on some tooling to get better, basically to help you like generate metrics on like accuracy relative to the non-quantized model. So yeah, you should be getting that real soon as well. So there should be a bunch of tools basically to help you out.
Yeah, I guess on that front, like what I'll be using like the scikit-learn like benchmark data set. So it's like there's the IRIS one, MNIST, as well as like the breast cancer one, and I'm not sure what's like the fourth one, but I think that should be enough. So yeah, I guess the other question is like are you gonna do like regression based models? Because right now I think it's mostly categorical models, so like you can have accuracy. So if it's like regression based, like will you be interested in some other like benchmarking figure?
Yeah, so far I'm only trying to measure accuracy on the MNIST data set. I think that would be just the starting point for me. So that's just classification.
Yeah. Yeah, I think that there's also like I guess it's like, for example, to run forward, I think right now it would create a new input JS on. So I think like one of the problems that I did face is that if you were to do that, you're gonna create like a heck ton of like input.js on. So so I think like one idea that I think might help with this is for like certain functions like forward on like PyZQL to not output a file, so it just output in memory. So would something like this be better for you, or it's like or would you want to output to a file?
Actually, how are you consuming this primarily? Is it through Python or is it through Rust or the Rust CLI?
For me, it doesn't matter. Like, I mean,
okay,
whatever works. I mean, I guess Python is like would be the most economical, maybe, if you wanted to evaluate on a larger data set. But I mean, I could work around any limitations, I guess.
Well, yeah, I think most of the tooling is going to be in Python. So
yeah. No, that sounds great. I mean, I got some examples working. Like measuring proving time is easy from just following the examples. And then I guess measuring accuracy would be, you would have to use the Python API to measure it, right?
Yeah, or yeah.
On the directions in the docs?
Did I find the directions?
I was just asking about feedback in general. Like, was it overall pretty straightforward to follow?
I just looked into it today. I found it easy to to basically like figure out the examples and figure out also how I would convert my own model so that I could prove inference. So that was pretty cool. I haven't used the Python API yet, so I will look into that later.
Yeah, let us know. Cool. All right, that's awesome. Yeah, keep us up to date. We've been wanting to run these sorts of experiments as well, so it's really cool that you're doing it. That's awesome. And yeah, I'll make sure to keep you posted as we start merging those PRs, so you can use like all of the calibration work and all that. Cool.
Thank you. Yeah, definitely looks like a super great project and really cool that it's so general to work with.
Yeah. Yeah, we've been aspiring to get everything to work with it as much as possible.
100%. Thank you, Georg. We can move on to EZKL versioning finally. This week we released version 0.1.0. You can see it on the main repo. And we'll also have versioning for PyEZKL. Dante, Jason, want to talk a little bit about that?
Well, I think Jason can speak more to it, but yeah, we finally have versions. So if we were breaking your pipeline every time we released or committed something new, then hopefully those days are over.
Yes, right. Right now on like EZKL and PyEZKL, so there are actually checks associated with all the various versions. So I think because EZKL is kind of like building pretty quickly, so so things like do change quite a fair bit. So I think like that has been a problem, especially when there's like breaking like changes to the API. So right now, what we're gonna do is like essentially tag every single release. So for example, one thing breaks, like have something to revert to. Otherwise, like there's no such thing like prior. Yeah. So for PyEZKL like just relies on the builds from the main EZKL repo. So they're kind of like separate but related like repositories. So like what PyEZKL is like supposed to do is like kind of get like all the data science tooling for Python and use it within like the Rust bindings itself. So you get kind of like the best of both worlds. But I think like Noya had like might have mentioned that like Python does have an overhead, like a kind of like a 15% overhead in terms of like the cost of generating a proof. So it might not be like the best of production use case, but it might be still like useful for research like applications. So I guess on the Python front, like if you guys have any kind of feedback, I think that'd be also great. So right now, I think like after the error measurement is up, but the next set of things that would be happening for PyEZKL is like more visualization tools. So like yeah, so because of Python, you can then include things like matplotlib and Seaborn, so you can do like interesting visualizations. I've been using things like plotly, so you can kind of like drag sliders to better understand like the models. So like if anyone has like things that you might want to add, like feel free to create an issue for that.
Cool. And third item on our agenda, thank you for that, Jason, is some new sections in the docs. So not only do we have an update on the WASM tutorial, we now have setup in WASM, which is cool. You don't have to run setup in the CLI or Python and then move to WASM. But we also have these new sections in the docs for just describing the commands for EZKL, the commands, the run args, and the parameters. So this was something that a lot of people wanted just more information in general about it. And it was really like a full team effort to put this together just to make it as descriptive as possible of what's going on in EZKL, what you can use. Granted, a lot of the run args are kind of abstracted with the new calibration PR, but it should still be helpful with just learning how this thing works, especially if you're just curious about the library. And then we also have a security section of the docs just so that you can be aware of some of the potential risks and vulnerabilities in using zkml. Not only security risks in the on the machine learning side, but then also on the zk side. But yeah, outside of those, Dante, speaking of that, you want to talk about the calibration PR? It's not out yet.
Yeah, so
It will be out soon.
yeah, so I mentioned this previously. I think one of the biggest pain points for folks using the library has been, and we've had like, yeah, a lot of the conversations we've had with folks have been about like what parameters like the bits or the log rows, or even how to pick the scale and how those different parameters sort of trade off another. Like how you might be able to get like faster proving times if you lower the scale in the bits. You kind of sacrifice that in exchange for numerical accuracy. And it can be kind of hard to hand tune those parameters. So we're rolling out a function, which is basically the calibration function, which allows you to optimize either for numerical accuracy or for proving time, depending on your like the application that you're building. And so you don't have to set those parameters by hand. It'll also make sure to select parameters that are valid so that you don't generate values that are out of range and those sorts of things. So hopefully that should improve usability quite a bit. And I think the plan will be to fold it into the Python export function. So basically when you export your model, it'll just calibrate the model at the same time and generate a bunch of plausible parameters for you, so that as soon as you've exported it from your Python notebook or something, you already have like a set of parameters that you can go ahead and use and that are going to generate valid proofs. So yeah, that's kind of the core idea behind it, is just to like make that whole process a lot smoother as much as possible. And yeah, I guess the other thing to talk about is something that I had promised that would be done the past week, which was the Poseidon hashing. So basically you can pre-commit to like a model input or output somewhere, and then you can also get the circuit to prove that any input that you feed in when hashed corresponds to that pre-committed to input, potentially like model weights or whatever. So for example, you can have like a commitment to a model on chain. You feed that into the circuit, but you want to keep the model weights private, but you want to keep them unchanging over time. So you want to prove that you're using the same model all the time, but keep it private. You can do that now with like the Poseidon hashing stuff. And similarly, let's say there's an input that you've committed to that you want to keep constant and just like run a bunch of models on. You can also do that whilst keeping the input private using the hashing stuff. But generally, I think this sort of foreshadows like some greater like cryptographic capabilities that are going to be baked into the library. So hopefully extending beyond hashing to some other sort of primitives that folks might want in ZK. And we kind of have the scaffolding to be able to do that now, which is quite cool. So yeah, if you have anything that you're currently doing with another circuit that you would like to fold into EZKL and just do it all in one fell swoop, yeah, definitely let us know, because we can probably, yeah, go ahead.
Yeah, I just want to also jump in and say that the thing that makes this really exciting, so hashing it's a small little op that you're adding, but it adds a lot to the compositionality, like the cryptographic constructions that it's possible to make that use EZKL as a component. And so we're really excited about adding it in, because it's really going to help move things from experiments to things that are used in production in bigger crypto systems. We built it for a couple of specific use cases that needed it immediately, but I think we'll see a lot of really interesting examples and new constructions that use it to connect pieces of data, inputs and outputs, and connect different proofs together. For example, you can have 5 different proofs that all have the same input and tie those proofs together using their hash functions. Using the hash functions, one proof can be a signature, which is produced by your wallet, and one proof can be produced by EZKL, stuff like that.
Awesome. And with that, we made it through the agenda in 17 minutes.
Perfect.
Does anybody have any questions though? Sweet. Oh,
Oh, we have a question in the chat. All right, type fast.
Hi guys, can you hear me?
Yes.
yeah, I can hear you, Zion.
Hi, I just want a quick question, since you guys were towards the end.
I think you just cut out.
Yeah.
It's going.
Oh yeah, sweet. Yeah, so Kathy, we have a bunch of, yeah, we have an example with a Jupyter notebook as well, if that's your favorite environment.
Actually, we also had new docs drop thanks to JSeam on the Python bindings. It's very descriptive, so we'd love to get your feedback on that.
Yeah, we also actually, yeah, we can share like a CoLab environment as well, where everything is pre-set up if you want to try things out without going through the whole install process.
Got it.
Cool.
Sweet.
Hey, Hadi, is your mic working?
I don't think so.
Oh, nope. Okay, cool. Cool. Sounds good.
Cool. But you could, yeah, you can also send the question async. I'm sure I'll respond. Cool, yeah. Or you can post it if you want everyone to see it. You can post it in the Telegram as well.
Mhm.
Okay, cool.
Okay, sounds good, Hadi.
Sorry guys, my mic cut off earlier. Could I ask a quick question?
Yeah, go for it.
Yeah, I had a question about the open issue on GitHub, the automated scaling, and I was wondering, like the work on that so far, or if that was something that needs to be like done more. Someone could help.
Unfortunately, yeah, unfortunately, we're about to close that. There's a commit.
Okay.
Yeah. Yeah, that's about to be completed just now. So it's part of the whole like calibration process. So you can pick like good scaling and other values. So yeah, there'll be a release and a bunch of descriptions as to how the command functions. But yeah, that will be done quite soon.
Okay, thanks.
I'm actually seeing 243 can be closed now. The WASM prover and verifier.
Oh yeah. Oh yeah. There's another question from Brent. As a side note, Jason, do you want to take this one, or should I kick this off?
Go ahead. I see.
Yeah, so there are projects that we've been exploring that would help with on the verifiable credentials front. Hopefully we'll have a post about those at some point in the future once they come to fruition. But yeah, it's definitely something that we've been thinking about.
Cool. Thanks,
Cool.
Brent. Awesome. So I think I can go ahead and stop the recording.